Hey, also, this is Math 116, Section 2.2, Quadratic Functions. And first I want to just go through some of the definitions. So from the last section, we had the quadratic formula. Where that's going to come in this section is down here when we're finding x-intercepts. We let y equal 0, which is that 0 equals ax squared plus bx plus c. And then if we can factor, we do that. If we can't, then we use the quadratic. And what that's going to end up doing is giving us the places the quadratic is crossing the x-axis. Coming back up here to standard form, that's the one that we're looking at in the last section. From standard form, to find the vertex, and the vertex is this point of the parabola. It's either the lowest point, or if the parabola is opening down, it's the high point. That's called the vertex. So to find the x-coordinate, it's negative b over 2a. It's just like the first part of the quadratic formula. And then to find the y-coordinate, we just take the x and plug it back in and get y. We're also going to see vertex form for just a second. This one isn't, we're not going to do a whole lot with this. We'll do just a couple examples, not something I test on. This is going to be the main point of the section, but we will see this for a second. And in this form, we'll see parabolas as a x minus h quantity squared plus k. When we're in this form, the h and the k end up being the vertex, and I'll show that when we get to it. A couple of the notes. Parabolas open up like this if we have a positive x squared, so if the coefficient in front is positive. Parabolas open down if we have negative x squared, so if we have a negative in front. So we can always tell just by looking at the formula which case we have. And like I said earlier, x-intercepts, we're going to let y equal 0 and solve for those. And for y-intercepts, we'll let x equal 0 and see where it crosses the y-axis. Okay, so question 1. Consider the following equation that find the vertex of the graph of the equation. Okay, so to find the vertex, that's at x equals negative b over 2a formula. And up here, it's written backwards, but our a is negative 1, b is 6, and c, if we needed it, was negative 5. So this will be x equals negative b, negative 6 over 2 times negative 1. So two negatives will make positive, and 6 over 2 makes 3. So that gives me the x-coordinate of the vertex. So now to get the y-coordinate, that was that f of this mess. What it's really just saying is we just take the 3 and plug it back in here and figure out what y goes with it. So negative 5 plus 6 times 3 minus 3 squared. And y equals negative 5 plus 18 minus 9. So that would be 14 from 18, so y equals 4. So the vertex is 3, 4. So that would be where the graph, well, I guess in this case, comes up and touches at 3, 4. That would be the high point. Which, okay, we just got to that question. Determine if the vertex is a maximum or a minimum. Okay, so let me say that a little slower then. So negative x squared means this thing is opening down, and the vertex is at the top. At x is 3 and y is 4. And so that's going to make that a maximum. C, determine what value of x gives the optimal value of the function. So what value x optimizes it? The optimum is going to be the high point, so they're just talking about the vertex in a little bit different language down here. So what value of x gives the optimal value would be the 3, and then what is the optimum value? That would be the 4, so that's the output. So this is the value that optimizes, and then this is the optimum value, would be the y. Okay, number 2, determine whether the function's vertex is a max or a min. So that is going to be, it's a negative x squared again, so it's going to open down, so that's going to be a maximum. And then the next part is find the coordinates of that point, so find the coordinates of the vertex. So we'll do x equals negative b over 2a. So b is this invisible 1 in front of the x, so negative 1 over 2 times negative 1/2 is our a this time. So two negatives make positive, the 2's cancel, so I think that just comes out to 1. And then here we'll do the y value. So y equals 1 minus 1/2 times 1 squared. So that'll be y equals 1, and then 1 times 1/2 is just 1/2, and 1 minus 1/2 would equal 1/2. So our vertex is at x is 1, and y is 1/2. So this is just a continuation of question 2. There just wasn't enough room on one piece of paper. So this is just the intro again, and then the next part is find any zeros if they exist. So that means we're going to let y equals 0 and x minus 1/2 x squared on the other side. I can factor an x out of there, and that will leave me 1 minus 1/2 x. And then setting each of those to 0, for that first one I just get x equals 0. And then for the second one I have 1 minus 1/2 x equals 0. I'll bring this over, 1 equals 1/2 x, and then multiply both sides by 2. And that will clear that fraction. So I get x equals 2. So those two would be my x-intercepts. Find the y-intercept. Well, it's going to be 0 again, because once x-intercept's 0, y-intercept has to be. But for that, what I'd be doing is saying y equals 0 minus 1/2, 0 squared. So we just get the same 0, 0 again. At this point, this is 0, 0. These are the x values, and that's the comma-separated list they'd be looking for. But in terms of graphing, that's 0, 0, because y was 0 in this case. When x is 2, y is also 0. And then sketch a graph of the function. So we know we have intercepts at 0, 0 and 2, 0. And then back from the last page, we had a vertex at 1 and 1/2. So x is 1 and y is 1/2. So that'd be right about there. And then that would be our graph. Okay, so question 3 is done. I'd have you guys try. Determine whether the function's vertex is a max or a min. This is written kind of funky, so I'm going to bring the y over, and I'm going to bring the 3 over. And I'm just going to write it in the order that makes a little bit better sense. 1/2 x squared plus x. So that became a positive y when I brought it over, and that will become a negative 3. And to me, it's just easier to look at if I write it in descending order with the y on the right side. So in this case, this is positive, so that means our graph is going to be opening up, and so the vertex will be a minimum this time. And again, we're finding the coordinates of the point, so that will be x equals negative b over 2a, so negative 1 over 2 times 1/2. 2's cancel, negative 1 over 1 will make negative 1. And then the y-coordinate, we just take the 1/2, or the negative 1, and toss it back in and find y. So y equals 1/2 of negative 1 squared plus negative 1 minus 3. So that's going to be y equals, this will be positive, so 1/2 minus 1 minus 3 will make minus 4. And then you could do a little 2 over 2 right here and make that 1/2 minus 8/2. So y is negative 7/2. So the vertex on this one, and for graphing, it might be easier to think of it as the decimal. Usually the computer likes the fraction though, but we can think of it as negative 3.5 also. So this is still question 3, and I just copied the equation to this next page so I can reference it. Find the zeros if any exist, and your answer is comma-separated list. So if I try to do that, I will have x equals negative b, so negative 1 plus or minus 1 squared minus 4 times a is the 1/2 times c is negative 3 all over 2a. So that would be negative 1 plus or minus 1, and then this would be negative and negative, so positive. So that's 12 over 2, which would be 6. And then here the 2's cancel, so it's just over 1. So x equals negative 1 plus or minus root 7. So if we're entering that as a comma-separated list, the first one would be, negative 1 plus root 7, and then negative 1 minus root 7. Find the y-intercept. Okay, so this is solved around for y now, so I'm just going to go 1/2 0 squared plus 0 plus 3. So, minus 3. Sorry about that. So then you can see the thing on the end, if we're in this form, is going to be the y-intercept. So y equals negative 3. or 0, -3. And then sketch a graph. So this one doesn't have the easiest numbers. Our vertex from the last page was -1, -3.5. So we'll go -1, -3.5 to the vertex. And then I think on the computer you just need 2 points, the vertex and one other point. So I would just use the -3 here, and I'll just use symmetry on this other side. And it should look something like that. If you do -1 plus √7, you should get this one. If you get -1 minus √7, you should get something pretty close to right there. Okay, so this is one we won't do a ton with, but just a little bit of exposure to it. The idea of this is called transformations, and we do a lot with it in 141, 142. Not as much in the business pre-calc and calc. So I'll just do a quick little intro on it. Y equals x minus 3 quantity squared plus 2. So this is what's called vertex form, and the h and the k are the vertex. And so the h, notice it has a negative in the formula, so this shows backwards from what it really is. So the h in this case would be 3, and then the 2 is the k. So that means the vertex of this is at 3, 2. And you can see if I put 3 into the formula, it shows as x minus 3. If I put 2 in, it shows as plus 2. So once I know how the vertex has been shifted, so it's over 3 and up 2, then parabolas, if you just think of plain old x squared, when you put in 1, they come out 1. So here when I put in 1, it will come out 1. And that gets me the rest of the parabola. Another way of looking at this is in terms of shifts, which is the transformations. And so the h, the number on the inside, if it's positive, it shifts left. If it's negative, it shifts right. So if it had been plus 3, I would have gone left 3. Negative, I go right 3. So that one's backwards what you'd think. And that's because of the minus in the formula. The 2 tells me it's going to go up or down. So plus 2 goes up 2. So I can just start from 0, 0 and say this is telling me to go right 3 and up 2. Again, this is an idea that we spend probably about 2.5 days exploring in 141. So this isn't something I test on, but just kind of consider it exposure. Okay, so for number 5, this is the match problem to the last one that I would have you guys try. So our HK, H is going to be -1 because it's always opposite what's showing, and K is going to be -4. So that means my vertex is at -1, -4. So x is -1, y is -4, would be down here. And then it just goes over 1, up 1 from there, as long as there's no stretch on it. Okay, so average rate of change is an idea that you'll see more in business calc next quarter. All it really is slope. It's rise over run. This is the average rate of change formula, but it's the same thing as this, just in function notation. And what it's doing is if we had some curve and we wanted to look at what the average rate of change was between 2 points, if it's linear, the rate of change is just the slope. But when it's curving, then it's different rates at each individual point. So sometimes the average is of interest. So if I pick 2 points and I look between those, what this formula does is gives me that slope of that line going through the curve. So what that will look like over here is we have this f of b minus f of a over b minus a. So this is our a, and this is our b. And then we're just going to find f of, and I think this time I will write it out, 4 minus f of -6 over 4 minus -6. So these will be our y2 minus y1 over our x2 minus x1. And f of 4, we just drop that right in the equation they gave us. So -4 times 4 minus 4 squared. So that's f of 4 minus f of -6 will be -4 times -6 minus -6 squared, all over 10. And I just have to try to clean this up and not make a sign error. So that's -16 minus 16 minus, that'll be 24 minus 36 over 10. So up front, that's going to be -32 minus -12 all over 10. So negative 32, that'll be plus 12, so it'll be negative 20 over 10, and finally I find that that slope is negative 2. So that would be the average rate of change. Okay, question 7 is the matched one I have you guys try. So average rate of change again, this time we're finding between negative 3 and 2. So that's our A, that's our B. Again, I'll just write out what I'm going to do, which is find f of 2 minus f of negative 3 over 2 minus negative 3. And then this is what we're plugging into, so we'll just do negative 5 times 2 plus 2 squared minus, same thing at negative 3. Negative 5 times negative 3 plus negative 3 squared. All over 2 minus negative 3, so that would be 5. So this is going to go negative 10 plus 4, and then 15, and then negative squared will be a positive 9 over 5. So this is negative 6 minus 24 over 5, or negative 30 over 5. So average rate of change is negative 6. Okay, and then to finish off, there's a couple application problems using some of this math we looked at in this section. So the yield in bushels from a grove of orange trees is given by this function where x is the number of trees per acre. How many trees will maximize the yield? So maximize means we're talking about vertex. So we'll take the formula they gave us, and I'm just going to distribute this out so it looks a little bit more like what we're used to seeing. Oops, 600x minus x squared. So we can kind of see our A and our B. If I write it descending order, negative x squared plus 600x. So B is the 600, A is negative 1. So x equals negative 600 over 2 times negative 1. So double negative makes positive, and x equals 300. So we have to be careful that we're answering the question they're asking. This is how many trees will maximize the yield. So it's not asking what the maximum yield is, it's asking for the number of trees. And back here, x was the number of trees per acre. So we have it right there. If the question had asked for how many trees, or what would the maximum yield be, then we'd have to put the 300 in and then calculate the y value, because that would be the max value, but it's maximized by the x. Okay, number 9, suppose the percent of the total workforce that is female is given by that big old function, where t is the number of years past 1970. Graph the function using a graphing utility. Yeah, no kidding, this would be awful by hand. On the homework, it's going to be a multiple choice. And so if you have a graphing calculator, you can use that. Or what I think is even easier is desmos.com. And it's an online graphing utility. And you can just type that right in there and zoom in and out with the mouse, which is way more convenient than on the graphing calculator. And you can pull up a graph of that pretty simply there. And then they also have a phone app too. Part B is from the equation, identify the maximum point on the graph P of t round to 2 decimals. So t, which is where our maximum is going to occur, because this is like our x, is going to be our same negative b over 2a. So that's going to be negative 0.38 over 2 times negative 0.0036. And I just kind of plunked that into a calculator and got 52.78 years. And then in what year is the percent of women workers at its maximum according to this model? So t equals 0 was 1970. And so it's supposed to happen, 3/4 of the way through the 52nd year. So we'll do 52, and then that would make it 2022. And again, it's maybe in September of 2022, but it's still in 2022.